Good morning. My name is Joseph Moriro. I'm studying Bachelor of Science, Honors in Network Security and Computer Forensics at Porto University. Today I'll be presenting Tau Logistic Transport Management System under the module QMD, Querying and Management Database. Um, the 11 slides that I have, this is the first slide. So let's go to the second slide where we have the, sorry. So here, that's my name, Joseph Moriro, and that's my student ID. Okay, this is the second slide, which is Introduction to Tau Logistics and Project Overview. So about Tau Logistics. Tau Logistics is a transport company that specializes in movement of goods across the country. The company manages a large fleet of vehicles, employs numerous drivers, and serves a broad range of customers. As part of its goal to improve operational efficiency and streamline processes, Tau Logistics is embarking on the development of a transport management system. This transport management system will help Tau Logistics to manage their fleet, to have statistics of like how much fuel is used from point A to point B, what shipments has been delivered, and what shipments that are still in transit, that kind of thing. Then still under the project overview, we have a project objective. The main objective is to design and implement a robust database system using Microsoft SQL Server 2012. This system will capture all essential data and operational logic of Tau Logistics. The system must: 1. Model real-world entities like customers, orders, shipments, drivers, vehicles, and routes. 2. Ensure data accuracy through normalization and referential integrity. 3. Support business rules such as driver and vehicle assignment logic. 4. Provide functionality for generating reports, tracking shipment statuses, and calculating shipment costs. Then still under this, we have our role. So our role is database developers. We are responsible for analyzing the company's data and operational needs, designing both the entity relational database diagram and the enhanced entity relational diagram to model the database structure, creating a normalizing relational schema, developing the database in SQL Server 2012, implementing queries, stored procedures, views, triggers, and functions. 6. Demonstrating and testing the system functionality with the real sample data. Okay, I'm gonna move to I think this will be the third slide. For some reason it's taking time to move. Okay, so this third slide is entity relation diagram, ERD, and enhanced entity relation diagram, EERD. So what is ERD? So an ERD is a visual representation of the entities in a database and how they relate to each other. It identifies the key elements such as customers, orders, shipments, and their interactions. ERDs are essential in database design because they provide a clear structure before any implementation is done. It's just like when you building anything or designing anything. Before you design, obviously you need to come up with a structure that will guide you on how to design, on what goes first and what follows next, and so forth. So this is the reason for having an ERD, and it's a very critical when designing a database to have this ERD. And the ERD for tower logistics include the following entities. These are the tables that we have in the will have in the database: customer, order, vehicle, shipment, driver, and route. Then on relationships, one customer can place many orders. Each order corresponds to one shipment. One shipment relates to one order, one vehicle, and one driver, and one route. Then we will go to the EERD. Uh, what is an EERD? So EERD uh, builds from the entity relationship diagram. Actually is delivered from the initial ERD by including additional concepts such as specialization, generalization, and categorization. In the case of the tower logistics transport management system, the EERD helps to lay out complex relationships, for example, distinguishing between different types of vehicles or drivers based on attributes like capacity or qualifications. In terms of vehicles, it could be truck, it could be van, that kind of thing. Then implementing this model ensures that all real-world data relationships are correctly captured, allowing for a more detailed and effective database structure aligned with tower logistics operations. So implementing an EERD helps model more complex real-world relationships and supports future scalability of the database system. Okay, we're going now to 4. So this is the assumptions made. So to ensure that we meet tower logistics requirements, a few assumptions were necessary, such as a customer can place multiple orders, but each order links to one shipment. Each shipment is assigned only one driver and one vehicle at a time. Vehicles and drivers must be available to be assigned to a shipment. Maintenance history is stored in the vehicle table. Then let's go to the next one. Then final normalized tables. This is a normalized table. All tables in the database have been normalized to 30 normal form to eliminate data redundancy and ensure data integrity. Each table has all those points listed, like eliminating repeating groups, partial and transitive dependence. Has primary key for unique identification. Use foreign keys to maintain relationship. Let's go to the next one. Here, these are the test runs. I just added 2 just because of space. I couldn't fit. I wanted to put 4, but because of space, only ended up putting 2. These are just 2 tests where I used to demonstrate the key functionalities of the system. So on top there, it's showing the any shipment that has been delayed, but as can be seen below, there is no shipment that has been delayed. That's why you're not seeing any line with any information there. Then below that we have this one, the other system functionality, showing the information about drivers such as driver ID, name, a license number, their experience, qualifications, that kind of thing. Next one. Um, this is the system output screenshots, um, showing the functionality as well of the system. So I've added 3 here, though they're not very clear, but you can see, like here, the bottom one is showing the um, route of a shipment. It's showing the route ID, it's showing the origin of the shipment and the destination, and as well as the time of the travel time for that shipment from point A to point B. Then challenges faced, yeah, obviously, like in adventure, when you're building something, there are some challenges that will creep in. On this one, we had things like debugging stored procedures with multiple joins was sometimes difficult. Maintaining normalization while allowing flexibility for future changes required. However, despite all these challenges, all system requirements for tower logistics were successful met. Okay, I'm going to the for future improvements. So for future improvements, play an important role in maintaining a scalable and robust system. For the transport management system, these may include, I'm just going to read the last two, enhancing shipment cost calculation with real-time fuel rates, introducing multi-row access control for customers, staff, and admins. Yeah, these improvements would expand system usability and operational value. I think I'm going to the last one now. Yeah, conclusion. So yes, we did design the ERD and ERD tailored to for a logistic operation, created full normalized database schema, implemented a core system logic via the queries procedure triggers functions. This transport management system is efficient, scalable, and meets the operational needs of tower logistics. Thank you. I hope I've explained or presented clearly, and hopefully I'll get a pass mark out of this. Thank you.